So in the first video this week, we learned about two different electrical classes of matter. We learned about conductors and insulators. Insulators are known to have no mobile charges, meaning that the protons and electrons or other charges in that matter stay in their fixed locations. And then conductors are known to have mobile charges. And I knew this before, but what I didn't know was that usually the protons are fixed and then the electrons are the mobile charges, but that isn't always the case. Sometimes these mobile charges could also be ions, and the video gave an example of this being salt water. And I was curious about this because that can apply to my area of study, because I'm studying environmental engineering. And I thought that maybe if these ions could create a charge, then you could somehow use ocean water or just salt water in general to create an alternate form of electricity, which would help to mitigate our impact on the environment. Next, we learned about how induced dipoles can be seen in insulators. An external electric field can still act on the insulator and cause that shift in charges, creating those induced dipoles. But because we're looking at an insulator, those charges are still not mobile. But however, this does create a non-zero dipole moment. And then we also learned about conductors in a sort of similar situation with an external electric field, which I found personally to be a little bit more confusing, but I took particular interest in the example they gave of the ionic solution due to my area of study, as I explained before. From my understanding and using the student wiki for reference, an external electric field can act on the conductor, causing ions to experience an electric force, which will cause the protons to move in the direction of that external field, and then the electrons will move in the opposite direction of the external field. And this movement is what causes the polarization and therefore the polarization field. This means that until the solution is sufficiently polarized, there will be a non-zero net external field and a steady dipole moment. I was curious about this idea of polarization and found out that there isn't only one type of polarization. In fact, I found an example of three, which were linear, circular, and elliptical, and they generated some pretty interesting graphs. We then went into more detail about conductors, and we learned about how there can be a net positive charge on a conductor that is in equilibrium, and this would create surface charges on that conductor. Specifically, we talked about how the charge would not be inside the conductor because it would create a non-zero electric field, and that would violate our equilibrium. So that would mean that the charges would have to be on the surface or on the outside of the conductor. Something interesting that was brought up was the fact that if the conductor has some sort of symmetry, then the surface charges would mirror that symmetry on where they are located outside or on the surface of that conductor. And obviously this was easy to comprehend when the example we were looking at was a symmetrical piece of metal with an even composition. And I assume that things are going to get a little bit more complicated when we move on to non-symmetrical objects, and I kind of wanted to see what that looked like. So I found some images that helped me picture this a little bit better.